Today I'm going to introduce the idea of being able to use a delay in your computer program. It's not a difficult thing to do, but you have to be aware of how XNA works to enable you to work effectively. If you've been working with Windows forms before, you may have come across the idea of a timer that allows something to happen at a regular number of seconds. We can do that in XNA, but what we have to do is we have to create our own timer, or in my case I call it delay. So to demonstrate this, I've just first of all set up a simple project that just has a sprite on there. Okay, so you'll be able to see already that I've created a sprite called enemy. So obviously we've got an enemy class, which is what we're going to work with in a minute. We've added the graphic for that and created that in the constructor for the game. And then, as we've done previously, we've located the thing on the screen. In this case, we've given it a direction. So at the moment, this has got a vector 2, which has got 1 in the x, which means it's going to move 1 pixel in the x direction at every screen update. And although we don't use it, I've set its radius as 31. And obviously, finally, we put that into the game components. So at that point, we've got a working sprite that's moving across the screen. Now what we want to do is we want to try and affect some sort of delay in that movement. So we want it to make, instead of it moving all the time constantly across the screen, what we want it to do is move a little bit and stop, and then move a little bit more and stop. Okay, and what we're going to work at is about a half-second delay, so a half-second pause as it moves so far across the screen. There's a little bit of extra code in here that you might want to look at in the project that also does things like stop the sprite from going off the screen, which might be useful to you, but that's not part of the discussion that we're looking at today. So what I've done is, if you look over here, you'll see there's a delay.cs file. Okay, so this is a separate class, and to try and do that, it makes it self-contained. It means we can reuse it whenever we want. So, you can bring this into any project that you want. So, how does it work? Well, for a start, we have something that specifies how long we want the delay to be. So we have a variable in there called delay rate. Okay, and we also have something that keeps track of the last time the delay ran out. Okay, because that's quite important. If we're going to make this work, we have to be able to do these things. So the next thing is it has a constructor, so something that happens when we create this as an object. And what it does is it takes whatever rate we specify in seconds, so if we want half a second it'd be 0.5, and stores it as the delay rate. So that sets it up in the first place. And it also sets the previous call time to 0. So that means that it's not been called before, so we'll be able to count from there. We also have a facility within there of a method called setDelay if we want to change that delay rate at any point, so maybe we wanted to make it faster or slower. And then we have some basic methods in here that allow us to do what we need to do in terms of check whether or not this thing's actually completed. Okay, so this is the important method, timer done. Okay, so this is going to return true if at any point the delay time has actually run out. So if it's half a second, it will return true after half a second. So that's what we can use to check in our rest of our code to see whether or not the time has run out. Now it works on what's called GameTime. Okay, now whenever you call an update method in XNA, you'll notice that it has a parameter. I'll show you on the enemy one. Update, and then it passes in GameTime. Now GameTime is a record of where we are currently in the game, how many milliseconds have passed. Okay, so what delay does is it uses that to keep track of time. Okay, so every update method, timer done gets called, and then when it finally reaches the point where the timer has actually run out, it returns true, otherwise it returns false. So how it keeps track of that is some fairly simple maths. Okay, all it does, it says, right, here's what the current time is, okay, and then we subtract the previous call time, so the last time the timer ran out. Okay, so if it starts at 0, obviously the first time this is called, it will be greater than the delay rate, so it will be greater than half a second. Okay, and at that point it will return true. Alright, so that's the math. It's really simple. The current time minus the time that the timer last ran out. Okay, so it'll start off at 0, slowly count up after each screen update, and eventually it will become larger than the delay rate, the amount of time. Okay. The only thing obviously is when it does run out and it returns true, we need to reset the previous call time to the current time. So that's all that does. It says take the current time and store it. Okay. If that hasn't happened, it just returns false, and that's how we detect whether or not that time is up. False means it's not up, and true means that it's run out, the time is finished. So the next thing we're going to do is we're going to look at how we implement that, how we actually use timer done and the delay class to set up a timer. Now I've created a sprite, and you know I've already called it enemy, and it's based on abstract sprite, which should be no great surprise to you by now. And what we need to do is, first of all, we need to create an object of type delay. Alright, so to do that, we just need to call back a new instance of our delay class. Okay, so here, this is the delay class that I created. Okay, and you notice it's got one parameter. Okay, and this parameter is how long a delay you want. So in this case, it's ½ a second. Remember that the f means that it's floating point. So we've created a variable called movement delay. Alright, and it's of type delay, and its delay is set at, well, obviously ½ a second, because that's what we've specified here. Now, that's fine, but for our code to work, we also need to have some sort of indicator of whether this thing's moving or not. So I'm going to create a boolean as well. Okay, so at that point we've created a boolean that says, is this thing moving on the screen, yes or no? Right, so we can switch that on and off. Every ½ a second we can switch it from false to true and true to false. Okay, which means that it moves and then it doesn't, and it moves and then it doesn't. So that's the basic principle of what we're doing. Okay, so we've got our class. We know that this movement delay is going to return true when ½ a second is over, and we've got moving set as false, which we can modify. So in actual fact, to use that is really, really simple. What we do is we go down to our update method. Okay, so here's our update method. We've already got the class prepared, remember, we've created it. And what we do is we add in an if statement. Okay? And all the if statement does is it calls the timer done method, sending in the current game time, which has come from here. Okay? So this will return false if the timer hasn't run out. Okay? And it will return true if it is. So that's really simple. So now all we're doing at that point is saying, right, this is our way of indicating whether we're moving or not. So we've got this line in here, moving equals not moving. Right, that's a very simple way of doing a Boolean toggle. Alright, so switching true to false and false to true. Alright, so every time this happens, it will toggle from true to false or false to true. It'll do the opposite, because that's not. Remember, not on Boolean inverts. So if it's true, it becomes false. If it's false, it becomes true. Right, and that allows us to have an indicator of whether moving's happening or not. The final bit of code is obviously to decide whether or not it's actually going to move. So there's a fairly simple trick to that. Okay, and I'll tell you about this stay on screen method at the end. We now have another if statement that says if it's moving, then we call the base.update method. Okay. Now fundamentally, if you remember, base.update in abstract sprite will automatically update the sprite's position based on its direction. And if we look back at our main game, remember I set its direction as 1, so that means it's moving 1 in the X every time. So this will update only when moving is true. So as a consequence of that, that means that we have now got a situation where every ½ a second moving is being switched from true to false. Alright, so, and then false to true. So for ½ a second it's false, and then for ½ a second it's true. and that will effectively mean that that sprite will start and stop every half a second, because that update method will for half a second not be moving, not being called, and then for half a second it will be being called. Okay, so this is where this sort of inheritance works. Stay on screen is an extra bit of code that I've written. It's fairly common stuff, it's things that you find in most sort of games programming. What it actually does is it reverses the direction of the sprite when it hits the edge of the screen. Again, it's starting to use a few shortcuts. The first thing it does is it works out where the next position on the screen the sprite's going to be. That's the new screen position. If it's less than the left-hand edge of the screen, so the boundary on the left, is it greater than the right-hand side of the screen, then we reverse its direction in the X, because obviously that's boundary left and right, it's moving X direction, isn't it? So direction equals minus direction X. So effectively, if it was a positive number, it becomes a negative number. If it's a negative number, it becomes a positive number. And then there's the same for the Y. So this will mean that now if your sprite's moving around the screen at any angle, it will bounce off the edges. The only thing I need to add to that is boundary. Okay, boundary is a rectangle, and that's been set up in the load content method. Okay, and what it's done is it said the boundary is the screen limits, but you could set that up to be something smaller than your screen. That's up to you. But what it does is it modifies the boundary based on the size of the sprite. Okay, so it means that it never disappears off the screen, it's always the edge of the sprite. So rough collision width divided by 2 is taken away from the boundary, and the same for the Y, and then we modify the width and the height of the boundary itself. So we get a rectangle on the screen that's smaller than the screen size itself, and the amount it's smaller by is the size of the sprite. So that's it really. I mean, there's nothing more to it. The update method gets called automatically because it's part of the game's components collection. All we really need to do is run this program now. And what we get is a sprite, because we said the direction was 1. It's half a second, half a second, half a second, half a second, and a little pause of half a second between each one. Okay. What the boundary bit does is it says, okay, look, you know, we need it to stop when that sprite hits that corner, so it's going to hit there, and then it rebounds and starts going back the other direction. Okay, and it will do the same on the other side. Okay, so that's what effectively we've got is this rectangle represents basically this area of the screen here, which has a border the size of the sprite on each edge. Okay, so about half that size there. Okay, so half a border there, half a sprite width there, half sprite width there, because we position our sprite by its centre point. Okay. Unfortunately, I can't draw that, but that's the principle. So, in summary, what we've done is we've created an enemy sprite which is doing its own automated movement based on a direction. The way we control whether or not that movement is happening or not is we use a movement delay which is based on a delay class. Okay, and we check to see whether the timer's done, and it resets itself every time it does, and then return moving on or off. It's like a light switch effectively, and then we use the if statement and that moving as a switch to say whether or not we call base.update. Okay, if we call it, it moves. If we don't call it, it doesn't, and it's as simple as that. Okay, so that's the basic principles. The obvious thing to say is I've just introduced a little bit extra about having another sprite in your game, alright, an enemy for a change. So we create a new enemy class that Abstract Sprite has provided all the basic facilities for, and then we've created some automation of that movement. So you may need to incorporate that in your game. You might want to do something a bit better than making it move left to right, but that's up to you. What I would say is it's worth studying this little bit of code or reusing it if you wish, if you want to stop your sprite from disappearing off the screen. Okay. There are other things we can do that make it wrap round to the other side as well, if you wanted that sort of facility, but this at least offers some sort of restriction. Okay, thank you very much.